Good day, class. I am Mr. Jude Anadozie. Sorry for being for this why I posted online. I've been having a few challenges on power, so I apologize. Today, as one of you comment that I taught the topic vectors, I'm going to start from the basic scratch of vectors and finish everything that have to do with what vectors. So stay glued to this page, to this channel. Everything from scratch, even though you're a novice, you have no understanding on vector, just stay glued on this channel. All you have to know, all you need to know on vector will be treated. So let's dive into the topic. Vector. Today I'll be looking at vectors and what? Vector addition. You know, some physical quantities. What are some of these physical quantities? Like time, temperature. You have time, you have temperature, you have mass, and some of them like that. You have density and so on. These quantities can be described completely by a single number with a unit. You know, time to be what? Second. Temperature to be degrees Celsius or Kelvin. Mass is kilogram. They can be described with what? A single unit that you know already. But many other important quantities in physics have what? A direction associated with them and cannot be described by a single number. Let me repeat myself. These ones can be described by a single unit, right? By a single number with a unit. Good. But there are other important quantities in physics that have direction associated with them. These quantities that have direction associated with them cannot be described by a single number, mass, kilogram. But there's a quantity that you cannot just say kilogram because it has direction associated with them. So a simple example is the motion of an airplane. We have the motion of an airplane, okay, motion of an airplane, or you driving a car, okay, assuming this position X. The position X is where you are with your car, and you have to drive to your working place covering a distance, okay, distance. You have to cover a distance of 5 kilometers to your working place. Let's assume it's on a straight path. We have a straight path here, straight path north, straight path east, straight path south, straight path west. And you have to move 5 kilometers. Now, there's a question here. Are you to move 5 kilometers north, south, east, or west? Hope you understand now. Now, you cannot just be talking about distance in this area now, in this scenario. So, distance now is not what we are talking about here. We are also talking about what? Direction. Direction. So you can see that we cannot just represent it represent it by a single number with a unit. Okay, 5 kilometers. Move 5 kilometers. If you move 5 kilometers, assuming your working place is 5 kilometers east. If you move 5 kilometers south, will you get to your working place? The answer is what? No. You won't get to your what? Working place. Another example is what? Force. Which in physics means what? A push or what? A pull exerted on a what? On a body. Giving a complete description of a force means describing both how hard the force pushes or pulls on the body and the direction of push or pull. Now, you're not joking, okay, you apply a force or something. So, you're applying a force, either you are pushing or you are what? Pulling. So when a physical quantity is described by a single number, we call it a scalar quantity. Once it is described by a single number, like these ones up here, we call those quantity scalar what? Quantity. In contrast, a vector quantity has both a magnitude. If you are talking about magnitude, you are talking about what? How big or how much. For example, 5 seconds, 20 seconds, 50 seconds. We are talking about what? Magnitude. So a vector quantity has both a magnitude and a direction in space. We are talking about vector quantity, vectors. We're not just looking at magnitude. We are also looking at what? Direction. All this here has what? Magnitude. But none of them here has what? Direction. Now, calculation that combines scalar quantities uses the operation of ordinary arithmetic. For example, 5 kilogram plus what? 2 kilogram. This will give you what? 7 what? Kilogram. So calculations or operation that has to do with scalar quantity use operation of what? Ordinary arithmetic. However, combining vector quantity requires a different set of operation. So scalar quantities, you can easily add them or perform arithmetic on them. But when it comes to vector, it's not so. We need what? A special what? A different set of what? Operation. So now to understand more about vectors and how they combine, we start with the simplest vector quantity, which is known as what? Displacement. Known as what? Displacement. Let's assume we have this. This is point A and this is point B. That is point A and that is point B. Displacement is simply a change in position of a body. I've once said about a man going to work 5 kilometers, north or south or east or west, talking about what direction. So displacement is simply a change in position of a point. The point may be a particle or what? A small body. Here we represent the change of position from A to B by a line from A to what? B. With what? There's an arrowhead on B. To represent this arrowhead is to represent the direction of what? Of the motion. Displacement 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 this displacement is a vector quantity because we must state not only how far the particle moves but also in what direction. Let's assume this is let's say 3 meters. So 3 meters in what direction? In this direction. But also like walking 2 kilometers to your working place. Walk 2 kilometers north. What if you now walk same 2 kilometers south? Will you get to your working place? No. Now you have the same magnitude, but different what? Direction. Different what? Direction. So we usually represent a vector quantity such as displacement by a single letter. Let's assume I use X. Represent by a single letter, such as in displacement by a single letter. Okay, yes. Then there's this arrow we do put on it. This arrow is to what? To indicate the what? Direction. This will tell you that this does not just have magnitude, it also what? Has what? Direction attached to it. Hope you are getting it. So we always draw a vector as a line with an arrowhead at its what? At its tip. The length of the line shows the vector's magnitude, and the direction of the line shows what? The direction of the line shows the vector's what? Direction. Displacement is always what? A straight line segment directed from what? The starting point to the what? Ending point. Even though the actual path of the particle may be what? Curved. Let's assume in a scenario like this, we have a man starting from point A. He walked 1 meter northwards to this point. Then from here, he walked northeast towards my direction. He will cover a distance of what? Let's assume 2 meters. From here, he moved again, covering some distance. From here, he moved again in this direction. From here, he moved again in this direction. Let's assume it's to this point. And he stops here. Let's assume here is 2 also, here is 3, and here is 1.5 meter, meters, meter. Now, if you add all this, you get the total distance covered. But if you are talking about displacement, let me use another concept. Okay, displacement is just from the starting point to the ending point. This is what displacement. When you see this arrowhead, they are this way. But watch this arrowhead. See direction. So if you have an angle like this go this direction, then continue this direction and stop. I want to get a displacement. Displacement will come this way. That single line that equals these two. Okay. Hope you're on the same page. So if two vectors have the same direction, they are parallel. Let's assume A to B, C to what? D. If they point toward the same direction, we say what? This and this what are what? Parallel. Let me call this vector A, vector D. We say they are what? Parallel. If they have the same magnitude, if vector A and vector B have the same magnitude and the same direction, they are not just parallel, but what? They are what? Equal. No matter where they are located in space. Are you with me? So, if also take note, if CD gave us the DC, now you can see now there's a change in direction now. From C to D is this, right? What if it's D to C? It's going to be what? Negative. Take note of that. So what did I mean? What I mean is this. From point A to point B, if point A to point B is like 5 meters in the direction east, B is east of A. Let's assume B is east of A. That means AB is 5 meters eastward. Are you getting me? Then BA is what? is still 5 meter, but no longer east, but what? West. Now, to show this change in direction, to show just this change in direction, as in this is vector A, this is CD. If CD equals A, DC, to show that the magnitude of CD and DC are equal, but it's just that it's in the opposite direction. It's not in the opposite direction. That is why this symbol, negative symbol, is now what? Added to it. Now, so what does it mean? CD and DC have the same magnitude, but now they are what? Opposite in what? Direction. They are opposite in what? Opposite in direction. And when two vectors have opposite direction, whether their magnitudes are the same or not, whether their magnitude are the same or not, we say the vectors are what? Anti what? Parallel. When two vectors are when they are opposite in direction, just as CD also have DC, DC now. Then this will be what? See the arrowhead here? See the arrowhead here? The same magnitude but opposite in direction, we say they are what? They are anti what? Parallel. They are anti parallel. So we proceed with the class. We usually represent the magnitude of a vector quantity by the same letter used for the vector, but in light italic type with what? With no arrowhead on top. So what does that mean? It means that if this is a vector quantity and I want to represent the magnitude, okay, Mr. Ben walked 5 kilometers eastward. I represent it with vector A, the 5 kilometer eastward, 5 kilometer east. Are you getting me? Now, I want to represent this vector quantity without referring to what? The direction anymore. I just want to represent the magnitude of this vector. So how will I do that? To represent the magnitude of this vector, I just write what? A. Now, I don't need to include the arrowhead on top, or if I must include this arrowhead on top, it will be in this format. So this, either this way or this way, whenever I see any of this, it's telling you what? The magnitude of what? A. By definition, the magnitude of a vector quantity is a scalar quantity, because scalar quantity has only what? Magnitude. Scalar quantity has only what? Magnitude. And it's always what? Positive. We also know that a vector quantity can never be equal to a scalar quantity. A vector quantity can never be equal to a what? Scalar quantity, because there are different kinds of what? Quantity. One is vector and one is scalar. 5 kilometers east is not the same as 5 kilometers. One has direction, that is 5 kilometers east, which is what? Displacement. And the other one just have what? Magnitude, 5 kilometers. So that's on what you should know about what? Vectors. So now move to what? Vector addition. Vectors addition. After vector addition will be true for today. till our next video. I'm having issue of power challenge, as I'm making this video longer. Let's watch to the end. So vector addition. In vector addition, what are the things you need to note on that vector addition? Now, suppose a particle undergoes a displacement. Undergoes this displacement. That is a vector. A particle undergoes this displacement, followed by a second displacement. The final result is the same as if the particle had started at the same initial point and undergo a single displacement. C. Okay, what do I mean? I mean that let's assume this is the first particle, first vector, okay? Then another starts from here to this point. Now, this is the starting point of the first. This is the ending point of the last particle. Are you getting me? So now, the resultant or the addition of them will now be this. Cover that this resultant starts from the beginning of the first and ends at the end of the what? Second particle. So now, if here is my B, here is now the what? C. So what does it mean now? It means what? C equals what? A plus what? B. That is what it means. So must it always be like this? No, it could be in any format. All you have to notice is this. Let's assume now that the A starts from here. Vector A starts here. Then at the end of A, B started. So where do you think our C will be? Beginning of A and ending of B, which will be what? This way. What is the direction of B? What is the direction of C? Sorry. So that is what you should know for now. So when we need to add more than two vectors, we may first find the vector sum of any two, add this vectorially to the third, and so on. But sometimes it's not always so. You may not need to what? Go through those stress. Let's assume we have like 5 vectors. This A move, and then B started from here. Then C, then D, then E, and it stops here. So in addition, the vectorial sum of 8, which is the resultant, will begin from here and will terminate here. So let's call here, should I say G or F? Okay, let's say F. So what does it mean? It means that vector A plus vector B plus vector C plus vector D plus vector E equals to what? Vector F. Vector F. So the sum of AB, I can regard it as what? I can say G. So G plus C is this, which is not compulsory. It's not mandatory. I can call this F. I can call this M. So what does this mean? It means that vector A plus vector B equals to vector G. Vector G plus vector C equals vector H. What does it mean? It means that vector A plus vector B plus vector C is written as what? H, vector H, because vector A and B is written as vector G. So G plus C give you this, and G is A, vector A plus what? Vector B. Hope you are with me. So vector M is same as what? Vector H plus vector D. So it's okay. I'm sure this first part you understand this first part. You understand this first part. What I'm saying here, vector A plus vector B equals vector what? C. So vector G, if no, equals vector G. Let me use capital letter. Let me use capital letter. Capital letter. Capital letter. So vector G plus vector C equals what? Vector H. So that means I can say, right, since the sum of these two equals vector G, so I can say vector A plus vector B plus vector C same as vector what? H. Hope you are with me. Equals vector what? H. And so on and so forth. So that is what I want you to know. Take note for now. In our next video, I'll proceed from here. Thank you. Don't forget to subscribe to the channel. Don't forget to what? Subscribe to the what? Channel. My next class, I'll begin from this vector addition and finish it up. Thank you.